part A of this question, you need to find the area of the shaded region. So if we could just find the area of this red shaded area, oh shoot, and then find this blue area down here, we could take the red area and subtract the blue area from it, and we would be left, I can't spell, we'd be left with what we wanted. So the area of the red is found by taking the integral from the intersection to 1, because we're trying to evaluate this area from wherever this intersection is, this line right here, whatever that x-coordinate is, to 1. And we just need the top function, which is the square root of x function. Okay. So to find out exactly where that coordinate is down here, you could use a calculator. Use the intersect feature on a calculator. Plug this into the y equals menu. Plug this into the y equals menu. And then use the intersect feature of your TI-84 or whatever. And that will tell you exactly what this coordinate is. And it should be like 0.239 right here. So for my integral, 0.239 is what I'm going to evaluate that from. That's my red area. I'm going to subtract from that my blue area, which is again from 0.239 to 1. And this time, the blue graph, the graph that's going to represent the blue area is e to the negative 3x. Again, if you're not sure which one is which, whether this line is the natural log or the e, you could use your calculator to confirm. But you find these two areas, you subtract them, and I mean, again, you could use a calculator for this, or you could use the fundamental theorem of calculus, but your calculator for the red area should give you, I guess I'm not sure, but when you subtract these two, you should get 0.442. So that's part A. Part B asks you for the volume. It wants the volume of the shaded region. And it's the volume of the shaded region revolved around this axis, the y equals 1 line. So you've got to envision this thing coming up in 3 dimensions, coming at you, going around the y equals line, going away from you, dipping down below, and swooping back up to this point. That area that's revolved. And to do that, we're going to use the washer method, where we take an infinitely small slice out of this. If we can come up with an equation for how big that slice is, that can and integrate it between the intersection of 0.239 and 1. That integral will tell us the area for that 3-dimensional piece. So just how do we find out the area of an infinitely small piece? Well, you can think of each of those slices that I'm making in black as washers, okay? Or washers, donuts, I've heard them called a lot of different things, but because the y equals 1 line is cutting it right in half, there's a gap here. There's a gap between each washer and the line. So a little space right there that we have to account for. And if we just find out the area of what this washer is, or the area of what this donut is, if we can find a function for it, we can integrate from the intersection to 1 of that function. That will tell us the area. So when we're slicing this washer, we need an equation for the area of this guy, and the area is found by taking the area of the smaller circle and subtracting it from the area of the bigger circle. So let's look at one slice right here. Okay, here's the y equals 1 line. Now the area of the smaller circle is going to be this difference right here. For that one infinite slice, the radius of the smaller circle is going to be found by using that blue line right there. And that blue line's length, okay, you could find it like this. We know this distance. We know that distance because we can get this y coordinate here from this equation. So if we could find out what that red dotted line is that I said, and if we subtract it from 1, that would represent, what would be left over would be this blue line here. Take 1, subtract the red line out of it, what's left is that blue line. So this is the radius of the smaller circle. We have to square that, and then multiply by pi. So now it's pi r squared, and this is the full area of the smaller circle. So the area for the larger circle is found by, let me get a different color here. Found by, we need the We need this total distance in orange here. Wait. Yeah, we need this distance, okay, because the washer we're dealing with, the blue was the area that we just found. If we could find the whole area of the orange and subtract the area of the blue out of it, we'd be left with the portion of the washer we're looking for. So we need to know this orange line right here, how long that is. And again, if we use the fact that the whole thing is 1, from here to here is 1, we can take this dot, subtract it from 1, and what will be left over is that orange area. And that's found by using this line. 1 subtracted by e to the negative 3x squared pi is the area of that orange washer. So I've written down here the area of our infinitely small washer. The bigger circle, the orange circle drawn over here, subtracted by the area of the smaller circle. And now that's what's being revolved around again and again. So we need to find out the infinite amount that exists between this intersection right here and 1. So to find out that area, we're going to integrate between 0.239 and 1 of this whole thing. You know, you're probably best off using a calculator for that. You could do it by breaking it up into individual pieces, but I'd punch that in your TI-84 as a y equals line, and then use your calc feature to find the integral from 0.239 to 1. And so when you do that, you should get 0.453 pi. If you punch it in correctly, this formula will give you 0.453 pi, or in other words, 1.423 or 1.444. For part C, let's take the first sentence. The region R is the base of a solid. So think of this as the bottom, and then you've got to envision it rising. There's a solid coming completely straight out at you from the screen. It's like 3 dimensions. If that region R was coming out at you, that's the solid that they're trying to get you to talk about. So for this imaginary solid that's, again, rising out of R, they want you. They say that each cross-section perpendicular to the x-axis. So perpendicular means a right angle with the x-axis. So there's a perpendicular cross-section if it went all the way from the top to the bottom. It's a rectangle whose height is 5 times the length of its base in region R. So an orange is the base, and the orange base is found by taking the square root of x, the uppermost function, and subtracting it by e to the negative 3x, this area down here. Okay, and that will tell you how long each one of those cross sections are. Well, they said each cross section is a rectangle whose height is 5 times the length of its base. So this is the base. So to find the full area of the rectangle, we take a base and we multiply it by a height. And they just told us that the height is 5 times the length of its base. So we got 5 times the length of the base. So for each one of those rectangular cross sections, when you simplify that, that's 5 parentheses square root of x minus e to the negative 3x squared. So again, we've got a formula, just like we had a formula for the washers in the past part of the question. For each one of those infinitesimally small cross sections, so between what was their intersection again? Between 0.239 and 1. Between 0.239 and 1, we need to evaluate this integral, and that will tell us the area of that solid. And so again, probably want a calculator for that. You could break it up again into pieces. It takes a really long time, but if you punch that in a calculator, it will give you 1.554 for an area. If you're wondering how to do this in a calculator, put this in your y equals menu. 5 parentheses square root of x minus 3 to the e to the negative 3x, parentheses, squared. Be careful, there's a lot of syntax problems you can have. Make sure you punch it in correctly and it looks just like this. Punch that in the y equals menu, and then hit second to get to your calc feature on your TI-84. And then there's a, there should be an integral symbol in there. I think it's option 7. If you tell it to integrate it and then tell it between 0.239 and 1, hit enter, it should give you 1.554.